Hi everyone. We're going to look at some problems that deal with periodicity of algebraic models. So again, we're talking about modeling, right? And we're talking about how do we take a real life situation and translate it into a mathematical expression using numbers and symbols. All right, so here or graphs, right? So it could be a algebraic representation, or it could be a visual, it could be a graphical representation, etc., etc. So here we have a problem that deals with the tides. And it says a sensor is attached to a dock to record the height of the water at high and low tides. The height of the water at high tide is 3 meters, and so this can represent our maximum value, while the height of the water at low tide is 1 meter. This could be our minimum value. Okay? The time between consecutive high tides is approximately 12.5 hours. Now this, of course, represents the period, right? Consecutive high tides, consecutive maximum values. 12.5 is our period. Which of the following graphs could model the situation if t represents time in hours and h represents the height of the water in meters? So again, important information here, correct? We need, the graph must show a high tide or maximum value at 3, a minimum value at 1, and a period of 12.5. Okay, so let's see which one of these has that. This has a maximum of 3, this has a minimum of 1, but unfortunately the period, as you can see, this period is very short. So from here to here is only about 6, it's not 12. So this thing, the period is too short. Okay, it's too small. It's only half of what it should be, 12.5. Here, maximum is 3, minimum is 1, and therefore, and then this one, but this, look at this period. This period goes all the way out to, what is this? That's going to be 25. That period's too long. Period should have ended right here, around 12.5, right? Right in here. Oh, as you can see this, well, let's take a look. We have maximum at 3, we have minimum at 1, and 12.5 is right in here. That could be a possibility, correct? One full period ends at 12, around approximately 12 and a half. So it starts at the midline, this is a sine function, right? Goes to the max, comes down to the min, and finishes here. So this could be an answer. So let's just put that there. Maximum is 3, minimum is 1, period is 12.5. As you can see, 12.5 is out here, and this thing, of course, the period is too small, right? Period for this one is only at approximately, what is this, about 8. So the period is incorrect. And there it is. Okay, let's take a look at another one. Decorative marker is placed on the spoke of Allison's bicycle wheel. The graph below shows the height in centimeters of the marker after Allison rides her bike on a flat surface for t seconds. Okay. Approximately how long does it take for the wheel of Allison's bicycle to make one revolution? One revolution, folks, represents one full turn, which is one full period, correct? So once around, which means it's one full curve, which is one full period. So how long does it take to make that one full turn? So it looks like it starts here at 25. Okay, so I'm going to say that's the midline right there. So it looks like a sine function, right? So it goes up to the max, goes back down to the min, and then when does it come back to around 25? It looks like it's right there, correct? Which is going to be between 1 and 1.5. So I'm going to say a little less than 1.25, right? Just kind of eyeballing it. So it looks like it's going to be a little less than 1.25, approximately how long? So let me see, that's 1, it's 1.5. That's going to be about 1, I'm going to say that's going to be about 1.2. maybe. All right, let's see. It's about maybe about 1.2 seconds. And that is correct. Okay, let's try another one. Okay. Sarah measures the amount of daylight D in hours in Boston, Massachusetts, every day for several years. She found that every year the amount of daylight increased between December 21st, which is the winter solstice, and June 21st, the summer solstice, as the days keep getting longer, right? So the amount of daylight is going to increase. And then decreased until December 21st. Okay, again, the winter solstice. Which of the following graphs can model the situation of T stands for time and days since Sarah began her measures? All right, so here it looks like, okay, just this particular problem, it looks like if we were to number, since T represents, stands for the time in days, we know there's 368 days in a year, correct? And so we know that starting around, what is it, June 21st to December 21st, December 21st is going to be roughly what, 355 days, I believe, right? So about 360, right? So about 355 days. So approximately, let's approximate, up to about 360 days, right? Starting from June, which is going to be right in the middle, right? So starting day number 180, so roughly. So starting from 180 to 360, we should see a decrease. But then from 0, which represents, January 1st, or 1, we should see an increase up to June 21st, which is 180. So approximately from 0 to 180, we should see the graph increasing, and then from 180 to 360, we should see the graph decreasing. All right, they didn't tell us how many hours it increased or decreased by, so we don't know that. But we do know from up to 180, the graph should be increasing, and from 180 to 360, the graph should be decreasing. Okay, so again, from 0 to 180, it should be increasing, and from 180 to 360, it should be decreasing. This looks pretty good. Okay, number of hours of daylight. How about here? Wow, this doesn't even account for a month, correct? So we don't even know what month they're even talking about, and this kind of makes no sense either, right? Because the number of daylight hours increases and decreases like this erratically over a month. I don't think so. How about here? Okay, this goes way beyond 1 year, right? This is for, I think, 2 years. Okay, so that doesn't make any sense. And let's take a look at this thing. Well, no, this doesn't make sense because it's saying that it's increasing, the number of daylight increases. This goes by fourths, right? 360. So it increases, number of daylight hours increases for the first 3 months, and then decreases the next 3 months, and then increases again. No, that doesn't make sense either. So it looks like A is our winner here. Okay. And then finally, an object is attached to the end of a stretched spring initially. The object is at a height of 5 centimeters. So we have a string and it's stretched. Okay, initially the object is at a height of 5 centimeters. The graph below shows the height of the object in centimeters t seconds after the object was released. Well, if it's stretched, if the spring is stretched, okay, and it's at a height of 5 centimeters, then what's going to happen is when it's released, then the height, I believe, is going to increase, correct? Because this thing is suspended from a spring that's been stretched. So it's upside down. Okay? If I had to kind of give you like a little visual, right? Maybe it's like this. It's attached somewhere here. And let's say here's the spring, and this thing is stretched. So here's the object like that, and it's been stretched. And so what's going to happen after it's released? The object, of course, is going to shoot back up, right? The spring is going to compress, right? And it's going to go right back up like that. Okay? All right, so therefore, what I'm saying is that the height is going to increase. The height is now going to increase here, right? Like that. Now, let's take a look. It shows the height of the object in centimeters. So definitely, as you can see, when it's released, it's at 5, but then the height increases all the way up to, what is this, 11, right? Because it goes in twos, like halves. So 10.5, 11. So the height already increases up to 11 up here, okay? Within less than 1 second, I believe. T is in seconds, right? Okay, so it says, approximately how many seconds does it take for the object to return to its minimum height? Okay, so again, what's the period they're asking? So how long does it take to get from here to here? And so we can see clearly that this is marked off by half seconds. So half, 1, 1.5. So it takes 1.5 seconds for this spring at minimum height to go up to maximum height and then come back down to minimum height. And this is the period, which is 1.5. Okay, so it's 1.5. Let's check. And that is correct. Okay, guys? Take care.